In Exploration 1, we are going to look at atoms, elements, and compounds. Now, I think you guys have been introduced to atoms, elements, and compounds before, maybe in 6th grade, so hopefully some of these terms sound familiar. If not, we'll go over everything again, but you should be familiar with most of the terms we're going to talk about. We might just go into a little bit more detail this time around. Now, let's start off with atoms. Atoms are the smallest unit of matter in the universe. Now, we said that a cell is the most basic unit of life, but an atom is the simplest unit of matter itself. Matter is very, very small, and as it says here, trillions of atoms could fit in the space that makes up a period in the sentence. And it is the interaction among atoms that is what we are going to be studying in this particular unit. All right, now, atoms have 3 parts: a proton, a neutron, and an electron. And I like the way this diagram describes those 3 parts, because sometimes diagrams are drawn with like a circle, and that's not really what an atom is. A better way to describe it is a cloud, where you have a very, very, very dense middle, followed by an area around the outside that almost looks like the sun. The protons are the positively charged particles that exist in the nucleus. The neutrons have no charge. Now, this is sometimes easily confused. Some people think protons positive, neutrons negative, and that's not the case. The neutron is neutral. It has no charge, but both protons and neutrons are what exist in the nucleus. It is the electron that has a negative charge, and it's the electron that exists in this cloud around the outside. Now, we use a cloud because electrons move at the speed of light, and maybe faster depending on who you talk to, but really, really fast. So we don't really ever say that they exist in any one point in space. We kind of just say they exist everywhere at the same time, which is a little bit hard to wrap your mind around, but that's probably the best way to represent where an electron is located, is just in the space that it could occupy around the nucleus. All right. Now, an element is a specific type of atom. Your textbook says that an element is a substance made up of one type of atom and cannot be broken into simpler substances. Now, that's true, but again, when you write down a definition, it's always important to put it in your own words. So I would recommend you write that an element is a specific type of atom and that it can't be broken by chemical means. Now, what does a chemical mean? We'll talk about that in a little bit. All right. But an element is what you've probably heard of before as something like carbon or hydrogen or nitrogen. These are all different types of atoms. Okay. And the type of an atom is determined by their number of protons. Different number of protons means that you have a different atom. For example, carbon has a different number of atoms than hydrogen. Hydrogen has 1 atom, carbon has 6. So when you change the number of protons that exist inside of an atom, you change the actual element that you're looking at. Okay? And that's the only thing that can change the element. The same element can have different numbers of electrons, it can have different numbers of neutrons, but it has to always have the same number of protons. Again, if you change the number of protons, then you are changing the element. All right, so let's talk about chemical bonds. A chemical bond is formed when 2 atoms try to become more stable with each other. And the way that they become more stable is by filling their outer shell of electrons. Now, this is sometimes tricky to understand, but in order to get a full shell, the shells kind of go in layers. So the very, very first shell only has 2 spots. Every other shell after that has 8 spots. And so in order to fill those 8 spots, sometimes different elements have to share or give away or acquire electrons in order to satisfy their missing spots in their outer shell. All right. Now, again, here I've highlighted this is important. The atoms of most other elements become more stable by bonding with other atoms. which is why atoms rarely exist alone in nature. There's a couple of atoms that you'll always find on their own, but for the most part, you're always going to see them paired up. Like your textbook talks about here, sodium and chlorine, whenever they're around each other, they are going to bond together to form sodium chloride, which is what we know as table salt. Okay. All right, so let's talk about the different types of bonds that form. Now, the first type of bond is called an ionic bond. An ionic bond is the strongest type of bond that can form because both atoms are highly motivated to make this transaction happen. In an ionic bond, you have one element, in this case sodium, that's trying to give their electron away. Because if they can give their one electron away, they will be to a full outer shell. Chlorine is trying to acquire one more electron, because if they can acquire one more electron, they will also have a full outer shell. So both of these elements are highly motivated to engage in this transaction, so it happens pretty easily. And that relationship is very strong because both of them want to keep that transaction in place. If this bond is broken, sodium goes back to having one extra electron, chlorine goes back to having one too few electrons, and neither one of them are very happy. All right. The second type of bond that can form is called a covalent bond. Now, a covalent bond is less beneficial than an ionic bond, so it's not quite as strong, but it still gives both elements involved the feeling of a more stable situation. Okay? In a covalent bond, the electrons are shared. So with chlorine, for example, this diagram shows you what a chlorine covalent bond looks like, because chlorine has 7 electrons. And if you remember, in its outer shell, you need 8. So chlorine is looking for one more electron to fill its outer shell. Now, normally it would look for something like sodium. But if there's no sodium available, then chlorine will settle for the next best thing, which is a partnership with another chlorine atom. What they're going to do is they're each going to kind of share their last electron with the other chlorine atom. And what that does is it allows them to kind of both claim that they have a full outer shell on both sides. Now again, this type of bond isn't quite as strong, but it's better than no bond at all. All right. Now this leads us to another vocabulary word. A molecule is any time you have 2 or more atoms held together by a covalent bond. All right, so for example, this particular one we would label as Cl2 because there are 2 chlorine atoms involved in this molecule. Okay, now obviously molecules can be huge. We can have more than 2 atoms involved. This is just a simple one to give you the idea. All right, now, the next term that I want to talk to you about is compounds. Compounds are substances where you have 2 or more atoms, but they're not equally bonded together. In other words, they're bonded in specific ratios. So here's 2 that are very common that we've already kind of talked about quite a bit. First of all, carbon dioxide. Second of all, water. Carbon dioxide is a compound where there is 1 carbon atom connected to 2 oxygen atoms. And this is going to form 2 types of covalent bonds between these 2. Both of these interactions provide a more stable outer shell for the atoms involved. But I want you to notice the difference in shape here. If you notice that a carbon dioxide atom has a slightly different shape than a water, it's because the carbon dioxide is balanced. The carbon is getting pulled on by each of these oxygen molecules pretty evenly. In the water molecule, the oxygen is so much bigger than the hydrogens that the oxygen is actually going to pull the shared electrons closer to itself and really not share it equally at all. Now what this does is it causes a charge to show up between those 2 molecules. Now we'll get to that next time. But there's a couple different ways that we can represent this. The one that we're going to use primarily is the structural formula, because the structural formula is just flat out the simplest to create. In the structural formula, we're just going to draw the letters that represent the atoms involved, and then we're going to connect those together with the number of lines to represent the number of bonds that are formed. Now, for the number of bonds that are formed, that's the number of electrons that are there. So there are 2 electrons being shared here and here, 2 electrons being shared here and here. Now, I think that's the end of exploration 1 for today. There's one more thing that I want to talk to you about. The properties of a compound are often very different from the properties of the elements that make them up. In other words, water is a very stable substance. We drink water. It's very important to us. It's not dangerous to dump on the ground at all, or you can't light it on fire. It's not going to explode. But water is made up of hydrogen and oxygen, and both of them individually are very combustible, very flammable, very unstable. But when you put them together, they turn into one of the most stable compounds on the earth. All right. That's it for this one. In our next exploration, we'll talk more about the properties of water.